Hi guys, welcome back. In this video, we are going to discuss about double integral dx dy as a function of area. If you are that means if you are going to integrate a function dx dy within certain limits, then we are going to get a area of those limits, area bounded between those limits. Just look at this. It is an ellipse with major axis as A. Just pardon with my drawings; these are not right, but this is also A and minor axis as B. It's B and it is B. Just consider an arbitrary square which has arbitrary rectangle which has length dx and breadth dy, right? If I'm going to feel like if I'm going to add small areas like this, if I'm going to add in the whole region between these limits, y is equal to b2 minus b and x equal to minus a2 plus a. If I'm between these limits, if I'm going to add small rectangles like that, I'm going to get the area of approximate area of this curve, right? This is the analogy behind finding the area of an curve by using double integral. Means simply integration means summation, right? If you are going to take single integral, I'm going to summate the things along a single curve in a single direction. If I'm going to take what we call double integral, then I'm considering two axes, like one axis which are perpendicular to each other. If one variable is moving in this direction, another variable is moving in this direction. Just if dx is considering forward thing and dy is considering lowerward thing, we are continuously summing up these values, continuously summing up these values, continuously summing up these values, and we are going to get the whole area of a given region, right? That's what the analogy behind using double integral for finding the area boundary between two curves. Just look at if you are going to look at an example, then we are going to get a clear idea about it. In the problem, it's given that show that area enclosed between x square is equal to 4ax and y square is equal to 4a. Sorry, x square is equal to 4ay and y square is equal to 4ax is 16 by 3 a square. Uh, to find the area between these curves, enclosed between these curves, we have to know the region first. So for knowing the region, we will draw graphs of the two functions. Just look at this. If y is x square is equal to 4ay graph and y square is equal to 4ax equation graph, right? And it is the area enclosed between the curves. If you are going to find the area between these curves by using conventional methods, like by using some of the formulas, it's almost going to be impossible because we don't know how the region is being formed between between these two curves. We have direct formulas for some fixed number of curves itself, and if we have to develop the formula for this region, then it's going to take lot of time. To save from those conditions, we are going to use double integral dx dy between certain range, I mean region, to get the area of this function. This region is nothing but the limits between which this area is varying. Yeah, these the what we call these are the limits of y for this area variation, and these are the limits for x for the variation of area. For variation of area, these are the limits of x, and these are the limits of y. Now I have these limits value limits of y, and I have this value also. Now a point has to be on this curve and this curve simultaneously, if and only if x equal to y, then only this equation, this condition will possible. Point of contact, because these are both just like when we closely look at these functions, both are same functions, but the variables are interchanged. That's it, right? So the for these type of functions, it is possible to have point of contact only when both the variables are equal. If I'm going to give this value x square is equal to 4a x then x equal to 4a, right? X will get cancelled and x will is the x equal to 4a value. Now I've got limits of x and limits of y. Limits of x 0 to 4a and limits of y are like this is equation of x square is equal to 4a parabola. If I want y value, y is equal to x square by 4a. This will give me the value of y on this curve. On this curve. Now, if I want y value on this curve, it's y square is equal to 4x graph. If I want y value, y is equal to 4a under root of 4x. No, I got the limits of y also. It's the lower limit and it's the upper limit. It's going from y square y is equal to x square by 4a x square by 4a to under root of 4ax. Now I'm going to integrate with respect to dx. Yeah, these are the limits of y. Now I'm going to integrate with respect to y dy first. Integral 0 to 4a, integral 0 to 4a. As there is no function of y, I'm going to get y. And I'm directly substituting the limits under root of 4ax minus x square by 4a between into dx. Now I'm going to integrate this value under root of 4a common. If I'm going to integrate root x, I'm going to get x power 3 by 2 by 3 by 2, right? X power n plus 1 by n plus 1. It's a basic formula. X cube by 4a into 3 between the limits 0 to 4a. I will substitute the limits directly. Under root of 4a into under root of 4a into 4a divided by 3 by 2 minus 4a whole cube by 12a. Right? This is going to be 16a square by 3 by 2 minus 64a cube by 12a. Just consider this 32a square by 3 minus 12 ones, 12 ones are no, it's not going to be 2 6 ja, 2 32 ja, 3 ja, 16 ja, means 16 by 3 a square. If I'm going to separate this value, oh sorry, here I think 16 a square by 3 by 2 minus 64 a cube by 12a. If I'm going to I mean further simplify it, 32 a square by 3 minus 16 a square by 3. If I further what we call simplify it, I'm going to get 16 a square by 3. This is what we proved, right? That's what here asked. Yeah, this is how we use double integral for evaluation of area bounded between two curves. This is all, guys, for this video. Thank you. Meet you in the next video. Bye.